Kia ora, my name is Giacomo Caleffi. I'm Italian. I've been living in New Zealand for almost 10 years now, and I'm actually a Kiwi as well a few weeks ago. And my background is in offshore wind. I used to be a structural engineer in London designing offshore wind farms a while ago. Then I came to New Zealand, 9 years ago. There wasn't much offshore wind happening at the time, so did other jobs. But then the opportunity for offshore wind sort of followed me around the world, which is pretty cool. And I'll tell you a little bit about what offshore wind is. You might have heard about it. Some of you already had heard about sort of from other developers as well. But I'll give you a bit of an overview of what we're talking about, what stages we're at of we're at very early stages or a very long-term project. And this is part of one of the presentations that I do. We have an office in Hawara. We do community presentations quite often there. I've presented in Patia and not yet in Opunake. So glad to be here in a very different environment from where I normally present, which is normally some kind of conference room or something like that. Pretty cool. We developed a way for Alison up there to go forward with the slides. This is how it works. I'll give you a bit of an update overview of what offshore wind is. Feel free to jump in anytime. Does anybody know much about what an offshore wind farm is? Just so I get a feel for, have you heard about offshore wind before? Maybe. Okay, I'll go with the basics and then feel free to stop me anytime. So first of all, I represent Taranaki Offshore Partnership, which is a joint venture of two companies. One is the New Zealand Super Fund, which you might know about. That's the sovereign wealth fund of the country. It's the commercial investor that receives money from the Crown and is tasked with investing it wisely to basically grow our pension pot. So if in the future we'll have enough pensions, it will be thanks to the likes of the Super Fund. And the other half is Copenhagen Infrastructure Partners, which I'm employed by, a Danish company, obviously, and a fund management company which works only on renewable energy, so only funds renewable energy projects around the world. And one of the leaders in developing offshore wind farms. We have them in the US, in Taiwan, two in Europe. We're currently building in most of the new markets around the world. And importantly, we're developing the first offshore wind farm in Australia, which started maybe 8 or 9 years ago. And that was sort of a bit the catalyst to start looking at New Zealand and the opportunity over here. So let's see if we go to the next slide. So what is offshore wind? That's a bit of an overview. You probably know about onshore wind farms. There's the one in Waverley, so a series of turbines connected to each other. We're doing the same thing, but in the sea. This is one of our wind farms out in Germany, the Yamate. It's 402 megawatts, so pretty sizable power plant, the size of, in terms of output, the size of the Stratford gas power plant. And the way it works in general is we have turbines installed at sea. They are connected to each other by subsea cables running on the seabed. And then all those cables converge to a central offshore substation. A bit difficult to see there, but it's a bit of a platform similar to Kupe, the one that you have off the coast here. And there the energy gets collected and then sent to land via cables again on the seabed. I always use that number megawatts, and then after a few presentations I realized not everybody knows what a megawatt is. So have a kind of, what is a megawatt, and I tried to give a feel for, this is a standard panel heater that probably most of us have at home for heating, so with an electric heater. That's 1 kilowatt, so a megawatt is enough power to run 1,000 of those. And offshore wind farms come in normally thousands of megawatts, so we're talking about million of power heaters running. Just to give an idea of what this number could mean. So one of the questions we always get is, why would you build an offshore wind farm? There's plenty of land. We know how to build onshore wind farms. They run fine. We like them. Why build them out at sea? Those are some of the sort of advantages that offshore wind has compared to onshore wind. Offshore, we get greater wind speeds. The wind blows much more constantly and faster out at sea. That means that we achieve what we call high capacity factor. Basically, think of it as a power plant that is more efficient in taking energy out of the wind and generating electricity from that. We can build bigger turbines, and that's how we achieve, again, better efficiency. And the reason we can do that is because we are not constrained by having, for example, to carry those blades around in the countryside. Those are built somewhere in Europe, probably in Southeast Asia, near a port. They go on a vessel, they come to the other side of the world, and they directly go out at sea. So that way we can build much bigger structures that actually capture a lot more power from the wind. And at least in Europe, one of the big things that sort of pushed wind turbines to go offshore is the fact that you don't really see them from land if they are built far enough. And I'll tell you a little bit more about where, if offshore wind happened in South Taranaki, what the visuals would be, but definitely nothing like driving under the Waverley wind farm. Very briefly, where does offshore wind come from? It's relatively new. It's sort of in the last 20-25 years, really, that we've cracked offshore wind. The very first offshore wind farm was in Denmark in 1991. That was a little bit of a sort of pilot study. They plonked 11 turbines out at sea, and it worked great. It actually finished its life only a few years ago. That was a bit of a sort of isolated project. Then, roughly 10 years later, again in Denmark, the first commercial size offshore wind farm with much more powerful turbines, and many of them. And then another sort of milestone would have been in 2017 in Scotland, the first turbines that were floating. So all the other turbines that you see there, and I'll talk about it a little bit, are connected to the seabed, but you can also build them floating so that you're not relying on shallow water. But I'll mention a bit more about that. So those are sort of some of the steps that offshore wind has taken. And nowadays we are building this, the bottom picture at much larger scale. Number of turbines, 80 is probably what we're still doing in most new wind farms, but we're looking at much more powerful turbines than 2 megawatts, around 15, for example. So what we are doing, and what the joint venture is doing, is exploring the feasibility of offshore wind in South Taranaki. I would like to be clear on that. We're not out there building anything. We are probably 10 years away from anything actually happening. We are in the very early phases of understanding whether it is feasible to build offshore wind in New Zealand in general, and especially in South Taranaki. And why are we looking at South Taranaki? On the left there, you have a map that shows the wind speeds around the country. Darker means higher wind speeds, lighter means lower wind speeds. And as you can see, there's quite a few areas that have really high wind speeds, as we all know. But especially South Taranaki, because of the influence of the Cook Strait, that creates that nice sort of funneling effect. We do get really, really good wind speeds, as in world-class wind speeds. That's the number one part of the resource that obviously we look at. On the right-hand side, I draw there 2 lines. One is the 12 nautical miles limit in yellow. So outside of that is called the exclusive economic zone, let's say outside the regional council area. And then the 60-meter water depth contour. So shallower than 60 meters is where we can easily build turbines connected to the seabed. Deeper than that, it starts becoming tricky, and it starts moving into floating offshore wind territory, which is a little bit more, let's say, not commercially ready quite at the moment. We're not quite there. So being able to fix the turbines to the seabed is a great advantage. So that area outside the 12 nautical miles means that we're at least 23 kilometers off from shore. And despite these structures being really big, at that distance, you would see them, on the horizon in a clear day, but they will be pretty tiny. And so that seems like a sweet spot for having that less visual impact, great wind speeds, and shallow enough water depth that we can install the turbines in a commercial sense. So not many areas around New Zealand have that combination of components. As a matter of fact, Taranaki is the only place where all these things happen. Out off the coast of Waikato, there is a sort of strip where the seabed is shallow enough that we could have a wind farm, but the wind speeds are nothing as good as South Taranaki. So you really have this extra resource that is, let's say, easy to use here. So that's another sort of view of the area of interest and a couple of bullet points around the project that we are considering. So yeah, it would be between 25 and 40 kilometers off the coast, mostly right opposite Howard and Pattaya, up to 70 fixed offshore wind turbines fixed to the seabed. Each machine would be 15 megawatts, and the total gives you a gigawatt, i.e. 1,000 megawatts of power. That would be the largest, most powerful power plant in the country. There's not many power plants that have that amount of capacity. And that capacity factor, again, is the measure of the efficiency of the power plant. 50-55%, very, very good. The average onshore wind farm in New Zealand is around 39% efficient. So 50-55 might not sound like a lot, but when you put 1,000 megawatts behind it, it becomes just a lot of power. So, I think we all read quite a lot about the need for new generation in New Zealand. Here we're talking about a power plant that generates it very efficiently with your wind resource. Any questions so far, or shall I jump into what building an offshore wind farm? Yes.
Talking about the geographical location,
Yep.
do you know how that overlaps or relates to the Prince Tasman?
Yes, I knew that seabed mining would come up. It does overlap in quite a large part, especially the eastern part of that region that I highlighted. That is now covered by Trans-Tasman's resources, the permit that they are trying to consent for. And it's a bit of a big deal, but I can talk about a bit more about that later. Sorry, did someone else have a question? Or no?
So can you coexist, or is that?
Very, very difficult. Certainly not in the same area. In the same area, I showed the image earlier with the cables running on the seabed. You can imagine that you cannot have a seabed mining operation in the same area. We're asking ourselves whether we could coexist, as in could have an offshore wind farm in that tiny spot left free from seabed mining, but it does raise a lot of complicated questions. That, again, we're at the early stages of a project that has a lot of de-risking to do, and adding another big risk like that is the kind of thing that often drives investors away. There's been 2 offshore wind farm developers who have already left because of that. And so we're kind of waiting to see what the government does, but there needs to be some sort of strong messaging there, because it's difficult to want to have the 2 operations go on, just consider them both viable at the same time.
So how have they got the jump on you? How's that?
They have a law, they have a legislation, the Crown Minerals Act. So they were able to apply as an activity that is already, I guess, enshrined in the law of New Zealand. We didn't have that. There's no law that allows offshore wind to happen. So that was their, I guess, starting, position. So we have a bit of work to catch up. All good questions?
So who controls distribution and who would own the wind turbines?
The wind turbines would be owned by us. We would build them. Distribution, the cables would land at the beach somewhere, at shore. And then from there would be a connection to the national grid owned by Transpower. And so there would be a sort of 10, 15 kilometer probably connection to the main 220 kV lines that run in South Taranaki. Transpower, we talk to them a lot. They are the owners of the high voltage power lines that you see all over the place. They would see this as an absolutely national significance project, because 1,000 megawatts, if everything goes well, it's great. But obviously, if something happened to our offshore substation and we came offline suddenly, it would probably trip the whole 2 islands. So Transpower would see it as an asset of national significance. So there would be they would probably be very much involved in running it alongside us. This is the kind of very good question. It's the kind of really big stuff that Transpower hasn't done in the last 30 years. So the last big assets like this connected to the grid were the dams in the South Island, and it's been a while ago. So. Main components of an offshore wind farm, the turbine, very similar to the turbines onshore that you see. There's some blades connected to a hub. They turn with the wind, and they generate power inside the nacelle up there. The only different thing is that we have a foundation that goes into the seabed and keeps the turbine standing up. And then some of the other components are obviously array cables. We have these cables that connect the turbines, and then larger cables that carry the electricity back to shore. The offshore substation that I was talking about looks a bit like something like that. And then on land, there will be an onshore substation. It's another piece of electrical equipment to connect to the high voltage lines that we were talking about. They're big. As I was saying earlier, the advantage of building offshore is that we can build much bigger turbines with much bigger components that extract a lot more power from the wind. So the wind turbines that you see at Waverley, the YPP wind farm, I think they are 4 megawatts each. And we are looking at 15 megawatts. So, it's 4 times more power. They are not 4 times bigger. They're roughly twice as big as the ones in Waverley. The advantage of building them near the sea and then having these specialized vessels that can lift them and move them around the world allows much bigger construction. That's what an installation vessel looks like. So that is, you see that it's called a jack-up vessel. It has those legs that go into the seabed and push the vessel up so that it becomes effectively a fixed platform from where we can do all the work. And then the vessel carries the towers, those cylindrical bits sticking up. There's a nacelle, which is the big part that sits at the top of the tower there, sitting on the deck. And then at the back of the vessel, you see the rack with all the blades. It's a pretty enormous operation, but it's very well organized. We can install an entire turbine in roughly 1 day. So that's pretty impressive. I was talking earlier about the foundations and how the turbines are connected to the seabed. The number one way of doing it, and roughly 90% of all turbines built installed offshore in the world use that method, is the one on the right-hand side, the monopile. So it's just a simple steel cylinder that gets hammered into the seabed, and it becomes a bit like a nail. So it's a strong point on which we install the turbine, and then and it's a very sort of simple engineering structure. That only works if the water is shallow enough, because the deeper we go, you can imagine it starts becoming like a really, really long stick, and it becomes really flexible, and it starts having engineering issues. So then we have to move to slightly more stiff structures like the jacket over there or the suction bucket. On the left-hand side, we have more of those floating concepts. All viable, but all viable for deeper water. Really difficult to make work from a commercial perspective because they require a lot of material. Like some of those, that semi-submersible that you see there, that structure is the size of 2 rugby fields or something like that. So the minute that you have to build 100 of those, it just becomes like a big thing. And so floating, which could definitely be the future for New Zealand because it would open up a lot of other areas around the country. We're not quite there yet. So we're looking at South Taranaki because it would allow the use of monopiles for installation. That's what a monopile looks like. Big steel cylinder. So we start with sort of flat panels of steel that get bent into shape, into a cylindrical shape. They get all welded together, and they end up being something like that. They can be around 110 or 120 meters long, and they can be 2,000, 3,000 tons. So these are really big components, which means that one of the big things that needs to happen in a country that wants to build their offshore wind farms is being able to receive these components at a port. And for that, I think we have, I have a picture later of what kind of upgrades would need to happen, for example, at Port Taranaki to receive components of that weight and size. You were mentioning seabed mining is the question that we get all the time. So, we wanted to clarify that obviously an offshore wind farm has an impact on the seabed as well. Those structures are installed in the seabed, but nothing at the scale of what TTR are proposing. So the monopile that gets installed in the seabed would be roughly 10 to 12 meters diameter, which is a big structure, but the turbines are separated roughly 1.5, 2 kilometers from each other. So you have that local disturbance of the seabed, and then the next turbine is 2 kilometers away. You have the electrical cable running in between, but that's all the disturbance there is. And once the turbines are in place, they just don't move, obviously. So, that's the kind of thing where we want to understand. We hear that there's quite a bit of opposition to the seabed mining proposal of using the seabed, so we want to be there quite early on, clarifying what kind of seabed disturbance there would be with offshore wind and getting that feedback on, is it better, is it worse, is it acceptable? I was mentioning Port Taranaki, so those components, the really large components I was showing, would be manufactured in probably Europe or Southeast Asia, and then they would have to arrive in New Zealand and be stored at a port while the operations to go out and actually install them in the location happen. So the ideal port would be Port Taranaki because it's the closest, it's a deep water port. On the left-hand side there, you see what a marshalling port back in Denmark looks like. That's a port that is entirely dedicated. It's the largest offshore wind port in the world. So fully dedicated to that. You can see enormous amount of land and really intensive use. We're not proposing absolutely anything like that. That is for building, 5 offshore wind farms a year. That's not what we're talking about in New Zealand. Port Taranaki ticks quite a few boxes. Again, deep water, and they have quite a bit of space available. But in terms of being able to host such heavy components, especially, there will need to be upgrades required. And so that's one of the things that we discuss with the port quite a lot. Where would the money come and when would the activities happen and all that? Obviously, the port would have to be ready if we were to build the offshore wind farm to receive the components. So that's the construction port. That only is needed, let's say, for the 2 years that it takes to actually build the wind farm. But then the wind farm runs for 30, 35 years. And during that time, we need to service the individual turbines almost daily. And so every day there would be crew transfer vessels, like the one on the right-hand side, going out. Those are 12 people vessels. They host 12 crew members. And they would be going out and visiting the various turbines to allow the technicians to access and do their work. For that, we need to be as close as possible to the offshore wind farm. And so, a few years ago, we've been looking at Pattaya as a potential harbor for that kind of operation, because from there, the sailing out to the area of interest would be roughly an hour and a half. We know about the sandbar and all that kind of stuff. Pretty tricky harbor, but that's the kind of stuff that those crewmasters would be dealing with. And so an hour and a half sail is pretty decent. It means that in the morning the technicians could jump on the vessel, go and do the work, and come back in the evening. Whereas servicing, for example, from New Plymouth would require a vessel that goes out and lives at the wind farm for, say, 2 weeks and then goes back, more like an oil and gas operation. So it's a pretty interesting opportunity. Obviously, you can imagine Pattaya is pretty interested in something like that. Again, we're at very early stages. We did a technical study to show that it would be possible to use Pattaya as a harbor. We would have to build harbor infrastructure and all that, but it's possible. And to be honest, it wouldn't cost as much as operating out of Port Taranaki. So interesting options there. Just a schematic of the various phases of an offshore wind project. We are at that very, very early left-hand side. Projects, even in established markets like back in Europe, they normally take 10 years between the idea and having it built, because they are enormous infrastructure projects that require a lot of lining up. So we're in that stage, feasibility and development. I'll talk a bit more about what that means. Then construction could easily just be a couple of years. We really try to put a lot of thinking into the design of the whole process, so that we, that vessel I was showing earlier, the one that installs the turbines, that's easily $500,000 a day of hire. And so we want to make sure that the vessel is used as quickly and efficiently as possible. Operation of the wind farm, roughly 30, 35 years. And then at the end, like with every power plant, there's the decision, do we decommission, do we remove everything, or do we repower, as in, do the foundations, for example, still have some life left in them? Does it make sense to install newer turbines, and so on? So the kind of conversation that happens at the end of every onshore wind farm's life as well. That first phase where we're now, just to give a feel for, a lot of people ask, why does it take so long to do that feasibility and development? These are all the things that we have to work on in those 3 to 5 years. We are working towards, you see there's 2 sort of milestones that I put there. One on the left-hand side is feasibility license, and then financial close. Feasibility license is, I was mentioning earlier that we don't have a law in New Zealand that allows us to build offshore wind. The main problem there is that there is no way to recognize site exclusivity on an area of seabed. So we could go out there and do all these environmental studies, geotechnical studies, and all of that, but there's no way at the moment for the government to kind of allocate that to us for all those studies. We will be going out doing a bunch of studies, and then someone else could come in and build a wind farm instead of us. That's the kind of risk that no investor can take. And so there needs to be some mechanism in place to allocate that feasibility to a specific company that then goes out and does the studies. So that's what we're working towards at the moment, and that's a bit the starting point for the really big work. So far, in the last 3.5-4 years, we've been doing everything there on the left-hand side, obviously wind monitoring, so understanding our resource, all the preliminary studies that we could do on environment, soils, community, having all these conversations with community to understand what the sentiment is, port studies and fisheries and constraints and all that. But to start kicking off the really big stuff, like environmental studies and geotechnicals, for example, which are the really expensive stuff, there needs to be just more sort of certainty around some kind of exclusivity for the site. Then there will be those sort of 3, 4, 5 years where we collect all of that other due diligence information, like, again, environmental, engineering studies, detailed design of the engineering structures. Offtake means who will buy the electricity that we generate. At the end of all of that, there's the final investment decision or financial close, which is when the investors decide, do we actually want to go ahead and build this thing? It can cost $200-300 million to get to the financial close. Building the wind farm costs roughly $6 billion. So that's an important moment where the investors want to go like, are we confident that there's enough support in the communities for this project, that the electricity is needed, and all that. So those are the main milestones in a project like this. I always get asked what happens at the end of the project's lifetime, and as I was mentioning earlier, one of the options is certainly decommissioning. Decommissioning projects like this get designed and built with a view of how we would remove them at the end of their life. And from a technical perspective, it's just the opposite than building them. So you disassemble the opposite way as assembling it. Up until a few years ago, the last sticky point was that the blades were really difficult to recycle. And so you might have seen pictures online of, especially in America, these sort of cemetery of blades that are abandoned there. Luckily, that's not the case anymore because the two main offshore wind farm developers in the world, Vestas and Siemens, have now figured out how to recycle the blades entirely. So now pretty much the entire offshore wind structure, which is steel, mostly steel, and then the composites for the blades is fully entirely recyclable. So that's a great step ahead in the industry. I was going to talk a bit about the permitting regime. This is kind of the laws that the government is putting together again to allow for offshore wind investigations, and then ideally, if there's feasibility is accepted, then a commercial permit. Probably not a Tuesday night read, but just to give you a feel, it's separated in 2 phases. At the moment, government is working on a regime to allow feasibility permits, which is what, if we held that at the end of the year, which is when we're hoping that the government will award them, that would allow us to go out there and start doing these environmental studies, for example, and geotechnical studies, with the certainty that if at the end, 5 years later, we were happy with what we saw, then we could progress to a commercial permit, which lasts for 40 years, and that permit is the one that actually allows you to go out, build structures, and then make revenue out of the wind that you're getting and having to decommission it. So that's set up similar to what we had in Australia, and it's sort of 2 stages, and many projects in Europe also work like that. Yes.
So you were saying previously that other
Yep.
so how many companies are still interested?
There's sort of 2 of us. There's various players. Some are a little bit less, let's say, experienced than others. So, offshore wind attracts some smaller companies that want to give it a go, and that's fine. we've found that it really helps, having built several offshore wind farms in the past. So of experienced developers, there's 2 left, us and one other. And yeah, the others, and then some sort of smaller developers. So that's the situation at the moment. The idea is towards the end of the year, we will all be applying for a feasibility permit, and it will become a bit of a shootout kind of a thing, because there will only be probably one allocated, one awarded, and so that's the idea behind it. It's a process that is expected to select the best developer for developing the first offshore wind farm in the country.
How long does it take for approval for a feasibility permit between applying and government awarding?
We're hoping maximum 6 months. In Australia, they said it would be 6 months. It turned out to be a year, which was a bit of a pain. But yeah, it's big stuff. The feasibility application will be something like us putting 700 pages together, where we tell all the story of the last 3.5 years, all the studies we've done, and all the experience we have, all the financial position, and all that kind of stuff, to show that, hey, we think we're in the best position to actually go ahead and do the feasibility here. And so if you think that government will be receiving 4 or 5 of those, I can allow them 6 months to think about it. A bit on the work that we've been doing so far. So this has been probably the main activity in the last 2 years. We've had a floating LiDAR installed out in South Taranaki. It's a wind measuring device. Obviously, as I was saying earlier, wind resource is the main thing that keeps us going, and we know from sort of, evidence that there's really good wind speeds, but we needed a proper reading. And so yeah, we had this in the water for roughly 16 months. You don't quite see it from the pictures, but sitting on top there where the solar panels are is this thing that looks a bit like a washing machine, and it's actually a super advanced laser that looks upwards and measures wind speeds, I think every 10 meters all the way up to 300 meters above sea level. And so that gives us a perfect profile of the wind speeds at various heights. And that way, as I said, we had it there for 16 months. We can have a full data reading for those 16 months of basically telling us what kind of power would we have produced in that time. That data set becomes a really important item for we call it bankability. So there's a day in the future where, if we agreed to build a wind farm, banks would probably provide something like $3-4 billion of loan, and they want to know that they are loaning to a project where the wind speeds are what we promised them. So that would become a sort of pretty important data set to show.
Well, it was there for 16 months. What have you done with it now, or why didn't you leave it there? You know what I mean?
What again? Say again, sorry?
You say 16 months of data.
Yep.
Is that enough, or is it still out there?
No, we pulled it in. It's a very expensive operation to keep it out there longer. So we are going to do 12 months, and then we extended it for a little bit. But no, it's been decommissioned now. Normally 12 months is all that we would need. So we got a little bit more than that. Especially because that data then gets used, for example, to calibrate bigger models of wind speeds. So we can download more generic wind speed models and then use the data that we actually recorded to calibrate those and get a much longer time series of wind. Yep. And this is the other big thing that we're doing at the moment. This is still deployed. So one of the things we heard from an environmental perspective from the very beginning is we don't know much about marine mammals in South Taranaki Bight. There's obviously quite a bit of marine mammal activity in the Bight. And there was a feeling from both experts and communities that we don't quite know how the marine mammals use the area. Is it, do they just pass through? Do they use it for breeding? And so one of the studies of interest that was flagged to us and that we started doing is putting underwater microphones for the detection of marine mammals and having them there in place to, again, map a little bit how the animals use the area. So we have 3 microphones in those 3 areas that you see there. That's the scientific study part that told us basically where were the optimal locations for those microphones in order to try and capture most of the area. And so having 3 of them will allow us, they will record, all the, especially blue whale calls, and we'll be able to triangulate and then have a bit of a map for those. This is meant to last for 12 months. We'll get a nice map of how the marine mammals use the area in that time. That's what the microphones look like. It's sort of these big tripods with 4 microphones each, and they get lowered onto the seabed, and then they stand on the seabed by themselves. The deepest we have is, I think, in 70 meters water depth. And then when it's time to pick them up, they have a pretty cool system, which is the operators ping an acoustic signal in the water that opens up one of those canisters that you see. Each tripod has 2 canisters, and that contains a buoy that will rush up to the surface, and they will see the buoy pop up, and then they can use that to pull up the instrument, change the batteries, and then chuck it back in for another 6 months. We have to visit them every 6 months. So towards the end of the year, we will have wrapped that up, and then we will have all this 12 months of audio recordings of marine mammals that will be analyzed by our scientists, and then we'll get a first sort of glimpse into the marine activity. That is all material that we will make available. There's scientific papers and so on. A bit of a video of deploying it. That video was taken by Alison, who is currently the projectionist. She's our environmental monitoring lead, and she's quite good on boats, but apparently that was pretty seasickening that day. I'm glad I didn't have to go there. Cool. So, as I was mentioning, we're doing a lot of work with communities because one thing that seabed mining did useful for us was apparently do everything wrong in terms of, provide us with a manual on how not to approach communities with a project like that, because it sounds like they did a lot of work so behind the scenes, and then they started asking, around, does this look good? We, as I mentioned, we're years away from anything actually happening, but we're keen to start being here already and hearing, what the opinions are and what the views are, and what is it that concerns you, what is it that doesn't concern you, what should we be focusing on going ahead. So we have quite an extensive operation in terms of again, getting that community conversation going. We opened an office in Hawara 2 years ago on Union Street. We use it pretty regularly for presentations. We established recently a community advisory group, which is a group with representatives of various communities around South Taranaki that basically can sort of be out there and feel a bit the pulse of how people are feeling about this, and again report to us what kind of questions there are that we can go and try and answer. Community benefits, projects of this size always come with quite a bit of community benefits. We've seen it in pretty much every market we've developed in. We try to avoid coming with a list of this is the stuff that we will do, because it seems more useful to just be out there and ask you guys what's the kind of benefit that you would like to see from a project like this, in terms of grants or scientific studies or stuff like that. So that's part of the conversation that we would like to have in the coming years. Iwi and Hapu, obviously it's a big part of the conversation that we have. The main things that we hear they want to be involved in from a development perspective is co-designing studies. So for example, being joining with us when we do our environmental studies and pointing out to us what to look at or what not to look at, and so on. And then there's also interest in this commercial partnership on the project. These are big projects. It takes a long time to set them up. When they are set up, they're good projects. They're nothing like oil and gas in terms of profits. We're not in that world. This is still renewable energy. But they're good, solid projects that run for decades, and in Europe especially, quite a bit of pension funds. Most pension funds are investing in projects like this because they have a long-term tenure. And we have expressed some interest in that for sure. Some of the environmental work we've been doing, just quickly, at the beginning there was quite a lot of what we called constraints mapping. So we went out there and basically created these maps that overlay all the various other activities that are happening in the area of interest. So we have to look at shipping, fisheries, are there any reefs, are there areas where we know about marine mammal sightings, and all that. So all that becomes a big map that suggests whether there are some areas that we should absolutely avoid or some areas that are a little bit more conducive. So certainly avoiding sensitive areas is the first step to try and have a project that doesn't sort of fold straight away. And we've been doing a lot of work with the existing literature. Obviously, oil and gas has done a lot of work in South Taranaki. There's a lot of information out there. It's a matter of putting it all together. So we spent quite a bit of time and effort at the beginning doing that. And we had for almost a year a technical working group with environmental experts running, where basically we were asking them to sort of give us a feel for, we know what the environmental questions normally are in most other countries where we develop, and some of them will be the same in Aotearoa, but there will be also some stuff that is only specific to New Zealand. So we asked to add that layer of what should we be worrying about more in New Zealand. One exercise that we've been running for almost 2 years now, and this is together with some of the other developers that are looking at offshore wind, because many of these studies we're doing together with them. This was initiated by us, but joined by another 2 offshore wind developers. We know New Zealand is a capital country in the world for seabirds. There's way more seabirds here than in most other countries where we develop. They are quite different from the European seabirds that we know well, and so it was clear from the early stages that we need a bit of a deeper strategy. So we have some of the main seabird experts in the country joined this sensitivity study, where we basically asked them to look at all the 186 bird species of seabird species in the country and sort of score them in terms of how at risk would they be with an offshore wind farm. That's kind of the question. You can imagine that each bird will have a scoring for, if it's a bird that flies really low on the water outside of the area where the blades spin, then that's probably lower risk than a bird that flies exactly at the height where the wind blades are. If it's a bird that is not in South Taranaki at all, then we'll be able to score it low. And so at the end of that, we'll get with a subset of seabird species that we know we have to be particularly mindful of. And then we know that we can tailor our environmental studies to a smaller group of birds, which is very useful. Offshore wind, it's a big industrial project, so we never claim that it will have no environmental impacts. We're here to talk about what are the environmental impacts that we should be focusing on and how can we mitigate them. We like to always also bring it back to the basics. This is renewable energy. It's meant to, get us away from climate change, which is a very, very real thing. And so there is a benefit to compared to generation from fossil fuels. And there's more and more studies that are showing that there can be environmental benefits from having these structures, these static structures in the sea, because they do become a bit like artificial reefs. If you then think that within an area of an offshore wind farm, there are some limits to fishing. For example, bottom trawling is normally not allowed because it could interfere with the cables on the seabed. It becomes a little bit like a marine reserve, and we're starting to see it in some of the wind farms that were built 10, 15 years ago. There's starting to be an abundance of fish that wasn't there for a number of years. So there are some benefits, and I guess at this stage it would be good to understand how much of this we could obtain for a South Taranaki wind farm, for example. We're getting towards the end, and then we'll open up for questions. These are huge projects that can bring a lot of jobs and development in an area, because we're mobilizing hundreds or thousands of workers. And so from the beginning, we always had the question, what kind of jobs could this bring? It's a question that we get in every market. So we know that one of the first things that we have to do in every new country is go through this analysis. The good thing is offshore wind can, a lot of offshore oil and gas jobs are almost directly transferable to offshore wind, because we're talking about being able to work in the marine environment with large machinery and so on. So it's quite fortunate that Taranaki has that obviously energy skills background. We ran for almost 2 years this industry capability mapping, which was again mapping what skills are available in Taranaki and how easily could they transfer to offshore wind. This is a map showing the jobs potential if we had a 1,000 megawatt project, so a gigawatt project being installed. How would the distribution of jobs happen? So There's a number of years where the jobs are that blue, really small line, which is the planning, which is where we're now. My job will be one of those. So all those, the planning and the managerial side of things, setting up the project. There's a few years of really, really intense, many jobs happening in the manufacturing and installing the wind farm. A lot of those manufacturing jobs will not happen in New Zealand. The monopile I was showing earlier with the welding, that doesn't happen in New Zealand. So one of the things we're trying to be very clear about right now is what's the potential for jobs in New Zealand and what isn't. And we're not in the business of fooling anyone. There's only a few countries in the world that can build structures like that. Not even my colleagues in Australia, not even them will have a factory that builds blades, for example. So there will be some jobs involved in the construction phase, but we think the biggest value will be that long series of yellow bars. So for the 30 years of operation of the wind farm, you have 100 and 150 highly paid, highly qualified workers working on maintaining the offshore wind farm. And so that's really where the value of a project like this lies. Obviously, we can try and get as much as possible of the construction work happening, of the construction workers happening, in New Zealand, mostly for the installation. So we could have some way of trying to get New Zealand crews on the installation vessels, but the manufacturing would be quite tricky. Yeah. This is a bit of a summary of the kind of numbers that we came up with the scenario of 1,000 megawatts offshore wind farm. We divided it in, we had Concept Consulting, which is a great consultancy in Wellington, who is really good at just thinking out the box and thinking about new stuff. These numbers are, we try to be quite conservative, not come up with ridiculous numbers, so we believe these strongly. Tier 1 jobs would be the direct jobs, basically the people who are actually working on as part of the wind farm. So the technicians that go and visit the turbines, or the people in the control room that control it from land, or the managers, or the commercial managers, and so on. Indirect work, and that would be roughly 70 people employed. Indirect are all those jobs that will pop up as a result of the offshore wind farm. For example, we would likely, I was showing earlier Patia as a potential harbor for maintenance, and I showed that crew transfer vessel that can go out to the turbines. Because of how rough the South Taranaki bight is, it's unlikely that we will be always able to go out with those vessels. We would also need a helicopter likely stationed in Patia. And so the helicopter pilot would probably be an indirect worker on that, because they would also service oil and gas or whatever else. And that would be another 45, 70 workers. Tier 3 induced, it's the minute that you have 70 plus 70 workers in a place like Patia or Punake or Hawera, obviously you need to start having some more, Foursquare employees or some more barbers or whatever. So there's all that induced economy. It's a little bit more difficult to sort of put numbers on that. And so again, we try to be a little bit on the cautious side, and you can see the gap is quite big. But the thing is, these are jobs that if they happen, they will happen in 10 years' time. And so when I do a presentation focused on jobs, when I say that, half of the people leave, and I'm like, okay, fair enough. But the idea is, unless we start talking about this opportunity now and trying to make those jobs happen here, they won't happen here. So if we don't do any thinking around how can we attract that talent here, retain that talent here, and we actually do get to build a wind farm, then in 10 years' time, it will all be workers that come from overseas, and it will feel like we haven't really done a service to the region. So really, we're putting a lot of effort into getting awareness, spreading awareness of this opportunity. I think this might be the last slide. It's really useful to have my colleagues in Australia doing a similar process 2 or 3 years ahead of me, because I can pillage a lot of their own material. This is something that we did in the state of Victoria, in Gippsland, a few years ago, setting up an offshore wind jobs guide. So it's basically a guide that lists the typical jobs that would come with an offshore wind farm and what kind of qualifications would be required. And we took it and we converted it into something that makes sense for New Zealand. So we went through and looked at all the qualifications and how you would obtain those in New Zealand, which ones are already existing, and so on. This is available together with the industry capability mapping on our website. If you're interested, or if you want to reach out afterwards, I can get you a copy. But it's pretty good reading. It's basically, the list of all the opportunities for someone who is in some cases maybe in high school at the moment, or but also workers who will feel the need to transition away from oil and gas, for example. I think that might be it. Yes. So there's my details there in case you wanted to get in touch. But other than that, you probably have some questions, and maybe we open it up, and feel free to ask about absolutely anything.
Yeah, the Australian one that you talked about 3
Yes.
years ahead.
Yeah.
So where's that at? Is that all go, or is it still?
It's a bit more go. The Australian government in those 3 years has developed a bit more of a strategy than the New Zealand government around how to connect these projects, for example, to the grid. As I was mentioning earlier, Transpower, right now we're telling them we could put a gigawatt into the grid in 2035. There's no mechanisms to make that, to plan for that. They're telling us we have those lines that are existing. At the moment, you could use those lines to add 1,000 megawatts into the system, but in 10 years' time, they cannot guarantee to us that capacity will be there when we get to connect. There's no, again, mechanism for Transpower to reserve that capacity for us when we connect. It requires a level of sort of strategy of someone who tells Transpower, you have to keep that capacity free for offshore wind in 10 years' time. Because, if in the meantime there's an onshore wind farm and a solar farm that gets approved in the same area, and they use up all that 1,000 megawatts, then we will be, in 10 years' time, we have built the turbines, we're ready to plug in, and there's no capacity left in the lines. So that's the kind of exercise that Transpower is not used to doing, and it was the same in Victoria, in Australia. But over there, they basically realized that they need offshore wind. It's a non-negotiable. They are about to close down a bunch of coal power plants, and there's nothing else that can replace their power sources, if not offshore wind. So the Victorian government has accepted that needs to happen, and has instructed their transmission entity, VicGrid, which is the equivalent of our Transpower, to start working towards making sure that the lines will be ready and so on. That's an example of the kind of thing that where Australia is ahead. The New Zealand government is very hands-off in terms of what you build where. At the moment, the view of the government is that they set up the regulations, and then anyone builds based on whether the market allows it or needs it. But it's very difficult to build a 10-year ahead project with that kind of view. It requires some strategy by government. And so most of our work at the moment is trying to clarify to government what it means to get something like offshore wind in place, if it makes sense. Yes.
Reassured that those blades are, you're saying, recyclable,
Mm-hmm.
than those kind of things that look like graveyards.
Yeah.
All of them just stacked up, which apparently is some countries are still doing it.
Yep.
I guess I'm really cautious about massive projects.
Mm-hmm.
I mean, does your company kind of consider the fact that planetary boundaries are being exceeded by quite a long way? And the period of time you're talking about, there's plenty of time for actually major collapse of global economy. You must have considered it.
Yeah, so you're talking about life cycle assessments of basically we have to ask ourselves if when we're building a new technology, are we going to extract from it more than it goes in? Otherwise, it's a net loss for the environment and the energy system. So
Yeah, and if you're doing that in terms of environment rather than finance, and you've got to consider it as well.
yeah.
That's really important, and I'm kind of impressed by what seems like the morality of the organisation that you work for. And I think you are comfortable working for this organisation. There'd probably be others who wouldn't. I don't know. Would you work for fossil fuel companies?
No, I wouldn't. That's one of the things that the blades, for example, now being recyclable. that was always, those graveyards that you talk about, it's true, that's the way it used to be. Blades were not recyclable, and so they used to be dumped in the middle of the desert. That was obviously not right for a sustainable, for a technology that tries to be sustainable. And the reason I love these projects and working for these companies is because they've always been really progressive from that perspective. That there was always the acceptance that that cannot become the status quo of a sustainable technology, and so it needs to be solved somehow. So the amount of money and effort that has gone into, again, projects that are only a technology that is only 20 years old, but I see it every year, there's more and more work going into trying to make it even more efficient, so we have to build fewer of them to get the same amount of power, use materials more cleverly, and so on. And now we're down to the point where one offshore wind turbine, and similarly an onshore wind turbine, you need to mine a lot of materials. You need to mine a lot of copper from somewhere in Chile. You have to send it to the other side of the world. You have to build all these very complicated components, send them all over. Often I get the question, you're using all that energy, surely the energy that you then produce does not compensate. It does, by many, many times. It takes roughly 4 years for an offshore wind farm to repay itself entirely from an energy perspective, from a perspective of all the energy that it took to actually build it. And then you have it running for 30 years. So it is a net positive build. And then, you have to also compare it with what's the alternative. Is the alternative to still be burning coal, to still be burning gas and all that? So is it the perfect solution? No, that will probably be fusion, nuclear fusion. But that's not something that we have right now. And so, I think it's a technology that knows it's not perfect, but does a lot to try and get as close as possible to it, if it makes sense.
It would be quite easy to look away from the reliance that even your company will have on fossil fuel. For example, bringing those gigantic things you showed us.
Yeah.
That's great. They look like huge pipes. I mean, they're part of that upright structure.
Yeah.
And to bring them here,
Yeah.
we can't make them here. They have to be brought here.
Correct.
They're going to have to be brought here with
Yeah.
fossil fuel.
Probably, unless by then we have shipping that is less emission intensive. I was saying it takes 4 years to repay itself. That was a study that we did, actually, that Victoria University did using our project as a kind of example. I showed that crew transfer vessel, the vessel that will go out to the wind farm every day to visit the turbines. At the moment, we have to assume that those vessels will be powered by diesel, because that's what we have. That puts us back quite a bit in repaying that environmental cost. So that 4 years is based on using using diesel engines. If we had electric crew transfer vessels by then, which is totally possible in 10 years' time, then we're cutting that time even lower than 4 years. It will probably become 2 years or 1 year. So just to say, you're right, there are some dependencies on fossil fuels that we will certainly be working on trying to reduce to maximize the amount of sustainability here. Yeah, thanks.
When you spoke about capacity on the current grid,
Yep.
do you mean, say, if we built another 100 onshore wind farms, for example,
Yep.
there wouldn't be a need for an offshore wind farm?
Yeah, correct. Then you have to ask yourself, how likely is it that we will build 100? Farmers, for example, will allow 100 onshore wind farms to be built. That's one of the other things that it's a bit tricky with government at the moment. There is a assumption at the moment that we can build infinite amount of onshore projects. We're having a bit of a hard time getting government to accept that they will need offshore wind in 2035, because we just don't think that there will be enough onshore wind farms and solar farms built. You ask a Meridian, you ask a Genesis, they all have this long list of projects that they are planning to build, but they don't have any incentive in actually building them all, because it drops the price and they need to, they need that price high. And B, there's just not enough sort of engineering brains, contractors around the country to build all that stuff. And that's one of the quite frustrating parts, actually, of having to point this out, having quite a few people in the energy industry confirming, that's probably the case, but we're still assuming that will happen. And so in some circles, it's kind of difficult to make the point for offshore wind, because we're saying, look, in 10 years' time, you risk not having enough power in enough generation in the country. And yeah, there's not a lot of people sort of jumping on board and saying, okay, we clearly need to solve that in the long run. There's this kind of hope that all the onshore projects, solar, onshore wind farms will all be built magically and that we will have enough power. And it's a bit of a tricky scenario to be in.
So how did you arrive at the 1 megawatt instead of 2, or 3, or 4?
Yeah, 1 gigawatt is, we think it's sort of the right amount. It's kind of we did a very in-depth market study to look at if you assume that not all the onshore wind farms that can be built will be built, we assume that roughly half would be built, which is already kind of generous compared to many other countries. A gigawatt is what's missing in 10 years' time. There's just a gigawatt of generation missing, which means we'll have blackouts and we'll have to use other ways of rationing the electricity. So it's a good number. It couldn't be much smaller because this would be the first offshore wind farm in the country. There's an economy of scale at the beginning that you need to make the most of. So building much smaller project becomes a lot more expensive. So they are big structures. That vessel that costs $500,000 a day, you need to bring it back for a good amount of time to make it worth it. So there's sort of a lower limit. I guess we could build 3 gigawatts, but for now 1 gigawatt seems like a good number. It's big, very big. So that's one of the main obstacles. It's at the moment it's difficult to see that happening in the grid, but it can be. I mean, we've seen it in every other market that has decided to have offshore wind.
Where do you see
Yes.
the price of electricity? Like, are you going to generate? And I know you're going to come back to the retailers and everyone else.
Yep.
Whatever, but at some point, are you generating electricity because you need to make a profit, obviously?
Yep.
So you're generating electricity today that it would be cheaper than what we're buying, or are you relying on the fact that the price of electricity is going to go up in the next 20, 30 years by a significant amount? You must have put some value on the electricity.
Yeah, the second one. It would not make sense to build an offshore wind farm now because from a price perspective it's not quite there. But we think in 10 years' time, because of not having been able to build all that onshore stuff, the electricity price will be through the roof if you didn't have something like offshore wind. So offshore wind brings down the prices in the future, where otherwise, if you don't have it, you're just having either blackouts or electricity prices that are way higher than what we have now. And so, it sounds a bit like a daunting future, but that's the reality of not having enough generation. It's what happened in September last year and in August last year, where there wasn't enough generation because of the lakes in the South Island being low. That made electricity prices go through the roof for a number of weeks. And most of us who have a retailer, as you say, the retailers are the ones who hedge all of that risk for us, and so we don't see huge spikes, although your electricity bill might have gone up like mine have. But anyone who was buying the electricity off the spot market directly would have been, for days, they would have been paying thousands of dollars a megawatt hour instead of 90. So that's the kind of volatility that having a lot more generation like offshore wind, where you have a lot more constant wind speeds and a more predictable generation than onshore wind or solar, for sure. That's where you get the benefits of a more, we say, resilient energy system. You need, if you want to go renewable, you need a lot of different options. So I'm not saying that we shouldn't build onshore or solar. Absolutely, those are all plenty of great projects there. We're just saying, relying on just the hope that all that will go magically well and will be built way faster than it has in the last 20 years, and not having some sort of insurance behind that seems a bit short-sighted. Sorry, did you have a
Why is the need to be outside the 12 nautical miles? What's the limit to being within?
there's no need to be outside. It's more of a visual thing, and it's at the moment a kind of convenient legislation boundary, because within the 12 nautical miles, if we applied for an environmental consent, we would do it with Taranaki Regional Council. Outside the 12 nautical miles is with the EPA, Environmental Protection Authority. If we had a wind farm that spanned both, it just creates a bit of a headache in terms of which authority considers, the application. But the reality is that we might have to have both authorities looking at it anyway. So it's not a hard boundary. We're thinking it's 23 kilometers offshore is a good distance to have the structures quite small on the horizon. So, maybe there's a future where we sort of start preparing certainly we'll do some renderings of what it would look like from the beach, for example. And if at 15 kilometers it's still, everybody is like, yeah, that's tiny enough, then maybe we'll say, well, maybe we bring it a bit closer. It's a lot cheaper if you can build closer to shore where the cables are shorter. So let's say it's a convenience boundary for now.
There's a servicing and everything would be.
Yep.
And we have them onshore now.
Yeah.
So,
Yeah.
Yes, there is some people that don't like the visual impact, but
Sure.
it's got to be compromised.
Our offshore wind farm in Australia that we're developing is 10 kilometers offshore, so it's a lot closer with the same turbines. So there, my colleagues are having quite a bit of conversations with communities on this is what your shoreline will look like one day. They're kind of lucky that because of the shape of the beaches there's actually only one community that will see the turbines quite in front directly, just opposite their shores, and quite a few of them are not happy, and that's it's their right to point it out, and so my colleagues over there have quite constant conversations with them on what are the benefits and what are the drawbacks. Yes.
Two questions.
Sure.
Sorry, the first one you may have covered. What's the overall square kilometre?
Yep. Roughly 250 square kilometers for a gigawatt offshore wind farm.
And second is, can you just explain a bit more this idea? Are you saying that some of the generators have got either consented onshore wind and solar farms that are unlikely to be built, or have they not got that far, and are they just ideas that the generators are talking about?
Yeah.
And why, apart from, I guess what you're saying is that compared to the rate of production so far, it's unlikely that they will be built. But
Correct.
can you just talk a bit more around
Yeah, sure. It's evidence that in the last 10 or 15 years, there's been quite a few projects like onshore wind farms, for example, consented and then never built. There's a big difference between consenting a project, which can be expensive, but unlike the likes of Meridian, probably doable. You still go through the motions, you get consent, and then you still decide, okay, do I actually want to build the thing? So that's one thing. Getting a consented project doesn't mean getting a built project. It's only if the commercials make sense. Building a lot of onshore wind farms will have the effect of lowering wholesale prices, because the more electricity supply we have, the lower the prices. That's the opposite of what commercially needing an onshore wind farm for the likes of Meridian looks like. They will go ahead with building an onshore wind farm if the commercials stack up, if the electricity prices look like will support the onshore wind farm. So that's, I think it's called, not sure I get it right, but I think it's called cannibalization of renewables, when you're basically building a new power plant, which relies on a certain power price to make it viable. You then drop the prices because you're there. So there's kind of this kind of feedback loop.
the only companies that are proposing to build onshore wind or solar, are they only generators, or are they predominantly?
Predominantly gentailers. By the way, I'm using Meridian just as an example. There's Genesis, there's Mercury, there's Contact, and they're doing all the right stuff. They're building some really good projects, and I'm not trying to discredit them in any way, but they are doing it based on the way the New Zealand electricity market works now, which doesn't really reward building ahead of time. It only rewards building just in time when you really need those extra megawatts, the price have gone up, and then you come in, you build a new farm and bring it down a little bit. That's where we see the issue of also just having the projects on paper and saying, I found this perfect onshore wind farm, it's perfectly buildable. You still have to go through what the communities think of it. And we see quite a few projects, stopping during the consenting phase. The fast track legislation that was put together last year has, with that, the new government aims to try and solve some of that, as in getting projects much quicker through consenting without too much input from communities. But we still don't think it will magically make every onshore project viable or go ahead. So we think consenting will be one of the main things that holds back that whole pipeline of projects to be built. The amount of power we could generate with this would require 7 onshore wind farms like Waverley, to be built. And so you can start asking yourself, is it really that much harder to consent and build something like this than 7 Waverley wind farms that all have to be consented, all have to be designed, you have to find the contractors, and you have to line them up, and you have to have them built in the right place, and all based just on the market doing its thing. So that's where we see a bit of a sort of hope strategy kind of a thing. Does that? Cool. Yes.
Where, if anywhere, this is very I've got a very small local view here. Where else in the world is there anywhere where it doesn't depend on the price that the generator can get rather than the need that people have for affordable power? The same in Europe?
Well, it's well put, that question. It's normally it will be by maybe the example of Australia actually is useful. As I was saying earlier, the state of Victoria has these coal power plants that have to be decommissioned. There's no doubt about that. They're running out of useful life, and they just have to be switched off. The people of Victoria still need that electricity. And so the Victorian government has reached that conclusion that how much will it cost almost becomes the next question. First, it's like, we actually need this. Are there any other alternatives? And there aren't. They could plaster the whole of the Victorian state with onshore wind farms, but they know that will never get them through, with consenting. So they've realized that they need offshore wind, and so the cost of it almost comes as a next question. And so the government at the moment is forecasting to have to support some of the Australian offshore wind farms with subsidies and grants because they just need them. And so, from that perspective, it's kind of disconnected from the market power price. And then the government will have to decide, where does that money come from? If it's not electricity bills, it might have to be taxes or so on. And so, in the end, everything has to be paid for. But it is that's still better than not having the lights, not being able to switch on your lights because there's not enough power. So, it's a tricky, moving towards a renewable world does require some sacrifices. We've been, often I get asked, this renewable world, electricity prices are too high. Maybe we've been used to electricity prices that were too low because we were using all the fossil fuels that were very easy to use. But, obviously we see what that has led to in sort of climate change terms. And so there will be some pain in moving towards a renewable world, but once we get there, it will be, I like the idea, personally. But
With your Australian example,
yes.
is it also privatised electricity provided?
It's the same. So that project is 90% CIP, Copenhagen Infrastructure Partners, so my company. And the other 10% is a C-bus, which is the equivalent of AAC. Oh, yeah. Sorry.
Back in the day,
Yeah.
electricity in New Zealand used to be provided by the state.
I see. Yes.
And then that got
Privatized.
yeah.
Yeah.
So is it the same?
Yes, it is. Yeah. They're set up exactly the same as New Zealand, and I would say most OECD countries. Certainly the ones in Europe, they're all set up the same sort of privatized way. Yep.
So ultimately there it's the will of the government that is enabling the market to take second place.
In a way, yes. Basically, governments are subsidizing what the market cannot achieve. You know, if the market would only, if you really need an offshore wind farm, but selling the electricity on the market will only get you so far because you can't really charge that much more, otherwise nobody would use the electricity. But you still need that electricity because without it you don't have the power. Then governments around the world have come up with, okay, we subsidize what's missing and enable this project that because we need the lights on, we enable the project to go ahead. That's kind of a way of thinking of it. New Zealand hasn't subsidized energy in the last 30 years, but the dams in the South Island were fully government built and where everything is running because we have those. So in a way, we're sort of lucky that we had that. There was that sort of foresight of building the really big generation back then. Right now, we've kind of gotten away with the market alone, sort of giving the signals to build onshore wind farms and solar farms in the last 10, 15 years, but there's been very little demand of electricity growth in the last period. So again, it's been a pretty comfortable situation in the last 10, 15 years. But now if we're moving towards a world where everything is electric and there's a lot more electrification around the country, not only of households, but I'm thinking the large industrials, the Fonterra and so on, a future where they're not using coal boilers but are using electrodes for their boilers. That's a lot more electricity needed, and so right now we're sort of hoping that it will just come from onshore and solar and so on.
So do you, like you must know what it costs you, or the minimum price you can sell the power for, right? Whether it be 10 cents or 2 cents or whatever. And obviously the gentailers are the people that actually fix the price that we pay. But if you were to cut a deal with, we'll use Fonterra for example, of Poiroa, would you be able to just sell them power for a flat rate?
Yeah.
That obviously if it costs you 5 cents to generate and you can flick it off to them for 20, which is still less than a day or whatever. Will that be part of, someone's going to win somewhere, right? It's not going to be the people sitting at home with their feet on the heater. Because they're going to pay the same price whether you generate it or whether the company generates it.
Yes, provided that, again, if you don't have that, you risk not having the heater on at all if there's not enough people that are generating power. So selling directly to Fonterra definitely could be a thing. That's one of the things that we look at a lot is large energy users, or the large energy users in the country. We approach them and we have conversations with New Zealand Steel, with Fonterra, with Methanex, for example, and try and understand what their desire for electricity in 2035 could look like. Could they use 1,000 megawatts of generation, really reliable, really constant in South Taranaki? If so, what's the price that they would be ready to pay for? And we don't have that answer right now, by the way. There's many years before we have a number that we can actually go out and sort of put out there.
I've got one other question.
Sure.
The government, you've said the government like a lot.
Yeah.
Where do you stand at dealing with the other parties? That the whole, it will almost be an election issue, but there's also a risk that the next government says we don't want it.
Yeah.
How do you deal with that?
These projects, if there's one thing they have to be, is very much supported by both parties. So I deal with both the ministers that are sitting, and I catch up with the opposition all the time. The current legislation that this government is developing, and they're doing a good job at that permitting regime I was showing. It's going quite quickly, so we're quite happy with the current energy minister. But that was started by the previous energy minister, by Megan Woods and the Labour. And so absolutely, the projects like this don't go anywhere if they become very politicized, because it takes 10 years just to build it. In 10 years, we'll flip another 2 governments. We cannot have it, being sort of overlooked by someone. I must say there's mostly sort of cross-party support at the moment. In the Green Party, there's a bit of, it feels like there's a bit of a split between a group, a wing in the Green Party that feels a lot more around degrowth and trying to promote a future where we're using a lot less electricity, and so they don't necessarily see the need for an extra 1,000 megawatts. But there's another wing in the Green Party which is a little bit more interested in that growth aspect. So I would say, there's no parties really that are strongly opposed to this. New Zealand First obviously has the seabed mining, so quite supportive of the seabed mining, and since last year when we started being quite clear around how incompatible the two activities are, I think we lost a little bit of favor with NZ First, or rather with Shane Jones specifically. I have some good conversations with MPs at NZ First, and they're quite supportive. I mean, it's large-scale industrial project, can bring jobs, clean energy. It kind of ticks quite a few boxes if done well.
I mean, okay, I'm not into the seabed mining.
Yep.
But let's compare the two.
Yeah.
What are they going to offer us, and what are you going to offer us? We're sitting here today.
Yeah.
What's the deal? Like, why should we say, you win hands down, or they win hands down?
Yeah.
If they're going to come and give us whatever, what are they going to do? I don't know.
Yeah. Look, I can't talk about them.
No, but that's
although,
the reality of it, isn't it?
yeah.
You might have a choice.
Yeah. So right now, right now we do need someone to make a bit of a choice. Is one of the things we, especially by politicians, who would love the idea of both things going ahead, because we're both saying jobs, we're both saying wealth for the country, and so politicians like the idea of both happening at the same time. We find it really difficult to think of a future where seabed mining is going ahead and we do all this stuff that I've been telling you about, because it just becomes such a risk to the investment that it's more likely that the investors will go like, well, let's pause. To be said here, we don't think that seabed mining will ever happen. That project seems completely impossible to deliver. We think they might get their consent through the fast track. We would be very surprised if in 5 years' time we actually have seabed mining operations. But nonetheless, the minute that they get consent, it would be tricky for us to, again, consider that we want to keep this project alive with that happening in the background. And so, what we're offering is all the stuff that I talked about. It's a project that can be delivered because we built a bunch of these all over the place. They're always successful projects, and they actually are useful. What they are offering is a bit of a different package, and there's some big dollar figures connected to that. But can it be delivered? Can it actually happen? That's what you have to ask yourself.
Do you have a plan B?
Plan B, very vaguely, would be Waikato. I was talking earlier about how the other offshore wind farm, possible area for offshore wind farms could be off the coast of Waikato. If South Taranaki became, if for example communities decided that despite all the environmental studies that we cannot mitigate the impacts enough that South Taranaki would suffer, then we would stop looking at South Taranaki. We would ask ourselves, is it worth looking at Waikato? The fact that the wind speeds are lower means a higher price of electricity needed to make that one run, though, because we need to, be generating less. And so that becomes all of a sudden a more expensive offshore wind farm to push ahead, and it would likely push things back a little bit. So we and the other developers feel that if offshore wind happens in New Zealand, it will be in South Taranaki, the first offshore wind farm. Yes?
I'm kind of encouraged that you think that the seabed mining is not going to go ahead, but why are you so convinced it's not? I'm almost convinced that it will.
Really? Probably as an engineer, I see the complexity of what they're proposing. It's like an incredibly complex operation, and we've been looking under the hood quite a bit of what they're proposing. They've done very basic studies on that's my personal view more than the project's view. On all the items that you have to look through, like all these studies that we've done so far are way more in depth than what they've done in the last 10, 12 years.
But does that matter to Mr. Jones?
That I cannot answer for.
No, but you're saying you think it's not unlikely that they'll give consent, but whether they'll be able to give consent.
the company that is applying Trans-Tasman Resources, which is owned by Manuka Resources back in Australia, is a really tiny company. They don't have, they're talking about needing $1 billion to set up the operations. They certainly don't have $1 billion. So the only way we see that happening is they are aiming to win the consent to then sell it to to sell the project to someone like, I don't know, Rio Tinto or some big, just dropping names. I don't know anything that you don't know. Yeah. So we assume they would sell the project to some larger mining company, but then to us the question is who on earth would buy that project? With knowing the level of opposition that there is in the communities and the number of times it's been sunk at sort of in front of consent authorities and so on. It just seems very unlikely. So
that almost sounds like a bit of contradiction in terms to the seabed mining is facing a community outrage on what's happening.
Yeah.
I don't see any reason why the community is going to have an outrage at what you're doing.
You don't see
I see exactly the same process. The community is going to take on board your project and object to it as well.
and if that's the case, we'll probably pack up and go. So far, it's been quite sort of supportive. I think, especially the fact that we've been out there talking about it way before any decision is made.
I like your soft approach on it, and it's great that you're here presenting to us.
Yeah.
But these things are the same size as the American aircraft carrier,
Mm-hmm.
and I don't think you've really put that across properly.
Oh, okay. Yeah. No, as I said earlier, we're not pretending like these things magically appear and they have no impact. They do have impacts on the environment, and they need to be managed carefully and all that.
These all got oil in them. What happens if one of those turbines breaks its bearings and spills oil into the sea?
Yeah, it's a very little amount of oil, and it has an oil catcher. But that's all stuff that it's worth exploring. Like, we would have an oil spillage strategy, but there's a very, very small amount of oil in there anyway.
That's still possible.
Yeah, of course. But then we have to go back and ask ourselves that we will never be able to build a power plant that has zero impacts on anything, right? And so I've been asked in a community presentation once. I was told I would support your offshore wind farm provided you can promise that it will never kill a single bird. I'm like, I'm not. I'm not. I can't do that.
I'm not here for that. But, these things do need maintenance.
Yep.
And one turbine replacement on that's going to cost you millions.
Yeah. It's all factored into the business case. That's part of why we spend so many years in understanding whether it's feasible to build. We will have, if we get a feasibility permit, we'll have our operations and maintenance team, which will do a whole study around, given the South Taranaki wind speeds, waves, currents, how often can we expect the turbines to break down? That gives us a total cost of maintenance, and then that's part of all this evidence that we will be building towards a final, does it actually make sense to build an offshore wind farm in New Zealand, so far from everything else, with the market prices that there are, with the operations and maintenance, with the job, with the energy skills that are available. There's a lot that goes into that final investment decision point.
Well, I wish you well.
Thank you.
Likewise.
Thanks a lot. Thank you. The best cinema audience I've had in a while. Or ever, maybe. Was there another question? Or okay. Cool. Thanks a lot. And any questions, feel free to get in touch. We'll probably, in around September or so on, we'll do another round of presentations in the Howard office, and that's normally every month we do, and we try to do a different topic every month. So we do 4 or 5 a year or so on. Yeah, thanks a lot, and feel free to get some food on the way out.